All right, today we are diving into some really fascinating research that's all about unlocking the secrets hidden inside our own voices. It's based on a project called Autolandwork, and trust me, it could completely change how we think about the link between our voice and our health.
I mean, just think about that for a second. What if the sound of your voice, not the words you're saying, but its rhythm, its timing, all the tiny little acoustic events happening inside it, could give doctors an early warning for things like depression? Well, this isn't science fiction anymore. It's a real field of research that just got a massive boost.
So here's our game plan. We'll start with the hidden clues in your voice, then we'll look at how scientists actually analyze sound, slices versus moments. We'll uncover a huge research gap that was holding everything back, and then look at the brand new toolkit that's changing everything. After that, we'll put some AI to the test, and finally, look ahead to the future of listening.
Okay, so let's start with this core idea, because it's a big one. For years, scientists have had this hunch that our vocal patterns hold a treasure trove of information about our well-being.
And here's the absolute key. It isn't what we're saying, it's how we're saying it. You know, those tiny, subtle changes in the timing and the way we produce sounds, those can be huge markers for all sorts of conditions. But to measure these things, you need tools that are incredibly precise. And that leads us to how we actually look at sound.
To really get why this new research is such a breakthrough, we've got to understand the two main ways scientists have tried to analyze speech. You can think of it like watching a movie frame by frame versus just zeroing in on the most important moments of action.
So, the old way, frame-based analysis, basically just chops up the sound wave into these tiny, equal-sized slices. The problem? This method totally ignores timing. It couldn't care less if you're speaking super fast or really slow. But the new way, landmark-based analysis, is way smarter. It doesn't just slice up the sound randomly, it pinpoints specific, meaningful moments, these things called acoustic landmarks.
So what in the world is an acoustic landmark? Well, the official definition says it's a point in time where the evidence for some feature is crystal clear. But let's make it simpler. Think of it as the exact instant a P sound explodes from your lips, or the precise moment a vowel sound begins. These are the critical moments that carry the most important information.
Now, this idea of using landmarks, it isn't brand new. Scientists knew it was a powerful concept. The problem was the entire field of research had basically hit a giant brick wall.
And the roadblocks were huge. First off, there was no shared public data set where these landmarks were precisely timed and labeled. I mean, imagine trying to train a self-driving car without any maps. Second, the software tools people were using were all proprietary. They were like black boxes. You had no idea how they worked. And all of this meant nobody could check each other's work or build on past discoveries. So the bottom line was simple and frustrating. Without a common map and a shared set of tools, the whole field was just stuck. Progress had pretty much ground to a halt.
And that is where this new research comes into the story. A team of scientists decided they weren't just going to try to climb over this wall. They were going to tear it down completely by building a brand new toolkit for the entire research community.
Yep, a team from the University of New South Wales, Johns Hopkins, and Nanyang Technological University all got together to create Autolandmark, a project designed specifically to solve all these problems we just talked about.
They focused on 5 key types of landmarks. And what's really cool here is how simple these concepts are when you break them down. You've got G for when your vocal cords start or stop buzzing, like in any vowel. B is for that little explosion of air and a P or T sound. S is for nasal sounds like M or N. And V and F are for those frictiony sounds like V, Z, F, and S. These are literally the fundamental building blocks of our speech.
And when they analyzed a huge amount of speech, this is the breakdown they found. The G landmark, the one for voicing, is the most common by a long shot. And that makes total sense, right? Because in normal conversation, our vocal cords are vibrating most of the time to make all those vowel sounds.
So here's the crucial takeaway. Their project delivered 3 things that are total game changers. Number 1, the map, the first public data set with these landmarks timed down to the millisecond. 2, the toolkit, an open source piece of software so anyone can use it. And 3, the benchmarks. They tested modern AI models to set a brand new standard for how well this can be done.
Okay, and this is where it gets really interesting. With this new data set and toolkit, they could finally put different methods, everything from old school signal processing to the latest AI, to a fair head-to-head test. And wow, the results are
well, they're pretty dramatic. The old method, on the left, had an error rate of over 56%. But look at that. The new deep learning models absolutely slashed that error rate, bringing it down to around 31. That is a massive leap in accuracy. They cut the number of mistakes by nearly half.
So the lesson here is obvious, isn't it? Just throw the biggest, baddest AI model you can find at the problem, and you're going to get the best results. Simple.
Well, not so fast. In this really fascinating twist, when they tested one of the biggest, most powerful speech AI models out there, a model from Meta called Wave2Vec 2.0, it actually did worse, significantly worse.
So why? What happened? It all came down to precision. That giant model analyzes sound in 20 millisecond chunks, but a lot of these crucial landmarks can happen just 10 milliseconds apart. The big AI's window is just too wide. It was basically smudging all these fine details together. It's an amazing reminder that for some problems, it's not about raw power. It's about having the right level of focus.
So let's bring it all home. By creating this shared foundation, the data, the tools, the benchmarks, this research has just blown the doors wide open for a whole new world of applications. I mean, the potential here is just huge. Imagine apps that could help with the early detection of dementia and Parkinson's, tools that give us a much better analysis of speech impairments, even things like advanced software to help you master a new language. And of course, it paves the way for much more accurate and accessible mental health monitoring.
And hey, don't just take my word for it. The researchers say it right in their paper, that super precise timing information is the crucial element that's been missing all along, especially for things like mental health applications. This new data set finally gives us that missing piece of the puzzle.
This work really gives us a powerful new lens to understand human speech, and it leaves us with this really big question. Now that we finally have the right tools to analyze the deepest layers of our own voices, what other secrets are we going to discover when we finally, truly learn how to listen?